All right, let's look at some graphing of our reciprocal functions. So we're going to talk just like our other functions. When we're talking about graphing, we're going to talk about what their parent function looks like, what kind of graph it is, and then some other interesting attributes of it. We're going to go into how when we change up things, how that parent function will shift and move and be a little bit different. And then we'll look at some examples. So our parent function of our reciprocal function is f of x equals 1 over x. Okay, so this one looks a little bit different. So if you have a calculator at school, then you can type this in and you can see what kind of graph it looks like. There we go. And if you don't, then you can go to that Desmos.com graphing calculator that we've been using. Now I will try to link to it as well. So this function looks like this on our graph. It looks a lot different than what we've been doing. So this is actually called hyperbola. That's what kind of graph this is. Okay. So I'm just gonna draw it here just to have in my notes. Looks something like that. You see there's two parts of the graph. Okay. So we are gonna look at if you were to make this real small, zoom out a lot, you will see, and then if you try to go up real high to x's, to your y's, or way off to the right or left to your x's, you'll see that what this graph actually does is it gets really close to your axis, either one of them, but it actually never touches it. It's going to get really close, but never ever touch. So that's something that's really unique about these kinds of graphs. And so they have what we're going to call a vertical asymptote and horizontal asymptote. So we're going to have a vertical asymptote here. An asymptote is just a line. So this is vertical asymptote. So then this one is our horizontal. I'm not going to write that out. And an asymptote is just a line that a graph gets really close to but never actually touches. And so that's going to be what makes this interesting is our domain is all real numbers, because if we go to the x's, it goes on forever this way, right? And if we go all the way to the right to the y's, it's still going to go all the way there. So our domain is all real numbers, except you see where it never touches? It's never going to touch where x is 0. So our domain is going to look like this. We're going to say x does not equal 0. Okay, so I didn't put that on your notes. So then same thing with our y's. Our y's continue on all the way here, and they continue on all the way up, but they're never, ever going to hit that 0. So same thing, our range of our y's is going to be y does not equal 0. So this is why this makes it interesting with our asymptotes, is that our domain and range is going to be written now as x does not equal a number, and then our range is going to be y does not equal a number. We're not going to have those number ranges like we were having before on some of our other graphs. Okay, so where is our vertical asymptote? Vertical asymptote is where x equals 0, and our horizontal asymptote is where y equals 0. Okay, so you're going to notice a pattern that whatever your domain does not equal to, that's what your vertical asymptote is going to be. And whatever your range does not equal to, that's where your horizontal asymptote is going to be. Okay, so not all of them are going to look like this, though, where perfect everything doesn't equal 0. We're going to be moving them and shifting them. So what our standard form looks like is f of x equals a over x minus h plus k. Remember, all of our standard forms for our equations look some form of this. There's an a, there's an h, and there's a k. And they all relatively mean the same thing. So if our a is negative, so if this is a negative number up top, and it's reflected across the x-axis, same as all of our other kinds of graphs. Okay, and if a is greater than 1, then we've got a vertical stretch. And if it's less than 1 but greater than 0, then we've got a vertical compression. And remember, the H represents our horizontal shifts, and that's right or left. And remember, the H's are with the X's, and our X's always lie. So if it's X plus H, then we're going to move it to the left. And if it's X minus H, we're going to move it to the right. And then our K, just like our other graphs, this is our vertical shifts, which is up and down. This one tells the truth. So if it's positive, it's going to go up. And if it's negative, it's going to go down. Okay, so for our graphs, we're going to be finding all of these things. So for this one, we're just going to go and look at where the vertical and horizontal asymptotes are, domain and range. And then when we get to these other examples, we'll actually list out these kinds of transformations. So we've got f of x equals 1 over x minus 2. And so we can already tell we've got the parent function minus 2. So we're just going to take this parent function and we're going to scoot it down 2. We're going to do nothing else besides scooting it down 2. So what you can do is go to your calculator, go to menu, the graph, and let's go back up. We're going to take that negative 1 over x minus 2. And we're going to see what that graph looks like. So you can see, I bet this calculator could tell you where the asymptotes are. But I don't know how to tell you. So we've taken that parent function and we've moved it down 2. So that means that instead of that horizontal asymptote being at 0, we've moved it down 2 here to negative 2. Okay. And then everything else stayed the same. So this is basically where our graph is. Yeah, I'm sure there's some way you can find asymptotes on that calculator. I just don't know how to do it. So where's our vertical asymptote? Where vertical, remember, is up and down. So where does it not hit up and down? Same, x equals 0. And our horizontal asymptote we moved it down 2, so it's negative 2. And then what is our domain? So remember what I said up here, that these two are correlated. So if our vertical asymptote is x equals 0, that means our domain is x does not equal 0. And if our horizontal asymptote is at y, then our range is at y does not equal negative 2. Okay, you see how those are correlated? So we only have to figure out one to figure out the other. So let's look at these. We've got, let me get here. 1 over x plus 3. So it says, is this reflected across the x-axis? we would need a negative a to be reflected. So no. Okay, easy peasy. Is it stretched, compressed, or no? Stretch is a is greater than 1. Compression is between those two. It's 1, so neither. Is there a horizontal shift? Horizontal shift is our H. Our H is the one with the X. Yes. And remember, this one lies, so it's plus 3, so that means that it goes to the left 3. Is there a vertical shift? Vertical shift is our X, and that's the number outside. There's no number outside, so no. So then what is our domain and our range? So this time we've moved everything to the left 3. So that's going to change our domain. So our domain is going to be X does not equal negative 3. And since we didn't move it up or down, y stayed the same at y equals 0. So this is where it helps to know. So this is where there's another correlation. Our horizontal shifts are going to be our domain, which also means that let's put this in. Our vertical asymptote is going to be at x equals negative 3, and a horizontal asymptote at y equals 0. So if we've got a shift, then that's where our asymptote is, how many ever over it is, and that's where our vertical asymptote is. And then if we've got a shift up or down, that's how it relates to the range. So let's do it. So this and this and this all correlate. They're all the same. This and this and this. You see how we didn't shift up or down? That means that y equals 0. And that means our y does not equal 0 for our range, and the horizontal asymptote is y equals 0. Okay, so let's look at this example. Is it reflected across the x-axis? And negative a is reflection. This is positive, so nope. Is it stretched, compressed, or NA? Stretched and compression has to do with the value of A. It's greater than 1, so we've got a stretch. Horizontal shift, remember that is our H. There is a minus 2, so yes, remember it lies, so that minus 2 means we go to the right 2. Is there a vertical shift? That's our K. Outside, we've got a negative 2, so yes, there's a vertical shift. This one tells the truth, so we're going down because it's negative 2. Okay, let's see how these correlate. We went to the right 2, positive 2, so that means that x is not going to equal positive 2, and our vertical asymptote is at 2. We went down 2, so our range, y is not going to equal negative 2. If we're going down, it's negative 2. And our horizontal asymptote is at y equals negative 2. And we can put this into the calculator to check ourselves. But same thing. Reflected across the x-axis. Is this a negative? Yep. So yes. Stretch, compressed, or NA. Our A is 1, so we're not doing either. Horizontal shift. Yes. We are going to the right 5. Vertical shift. There's a number out here. Yes. And we are going up 3. Okay. So we went to the right 5. So x is not going to equal 5. We went up 3, so y is not going to equal 3. Our vertical asymptote is x equals 5. And our horizontal asymptote is y equals 3. All right, let me know if you have any questions on our graph attributes of our reciprocal functions.